Hi everyone. We are going to be working on and doing the notes for simple interest and compound interest together. So this is going to be another long one. Again, please make sure you're keeping yourself organized, trying some of those try it questions, and uploading clear scans in one file of your notes before the deadline. If you need help with that, again, I'm available. Come on by office hours and I'd be happy to help with whatever you need. So simple interest is actually going to feel a lot like what we were doing with percentages, which is pretty great. It's going to feel pretty familiar, I think. Let's keep in mind about our goals about computing simple interest. Interest is in terms of future value, computing loans, dealing with a lot, again, money stuff. This is our money unit, okay? So simple interest. Well, first of all, what on earth is interest? Interest is kind of a unique, kind of different idea. Okay. So we need to talk about the different pieces of money that we will be working with and the amount that we start with. Okay. The initial beginning amount, it could be us, could be somebody else, is called the principal. 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 And I did spell that wrong. Just had to check. It is not principal. Let's get that right. Principal. There we go. Okay. So, and then the ending amount of money. Your book uses future value, but I like to use amount. That's amount at the end. A for amount at the end. Again, sometimes they use F for future value. It's after some time has passed. Okay. Now, the amount of growth, just the growth itself, is called the interest. The interest. Okay. And the growth is based on an interest rate, usually called some sort of APR or rate of growth. It is a percentage rate growth. Percentage rate. Okay. There are a few other different names depending on who you're talking to, what entity you're looking at. I'm going to try to stick with a lot of the ones that we see in our normal everyday usage. Okay. To find interest. Now, the interest we use, I want to pause. I want to pause for a minute. Okay. Our whole section on money stuff is about money in the real world. What is this interest? What is this interest business? It turns out that banks are businesses and credit cards are businesses and loans are businesses. And so this interest is some sort of growth that we need to keep track of when we want to buy things or use other people's money, or nicely, if like banks or other entities want to use our money. We get this sort of like payment for use of money called interest. Okay. Now, under simple interest says that the interest, the growth, is where you're just going to take the principal amount and you're going to multiply it by whatever that rate is. Let's go ahead and use R for rate times however long you're using the money for, whatever the time is. So we're going to let I be interest. P is going to stand for our principal. Remember that initial amount. R will be our rate as a decimal. Be careful about that as a decimal because that's how we use percentages. And T for our time, usually in years. And we'll actually have a couple of questions where that time will change up. And we'll see what's going on there. Okay. Now, overall ending amount. Well, at the end, the amount that you have that you need that is resulting from the situation can be found a couple of different ways. We really need to take our interest and our principal together. We need to add those up together because we still have the initial amount of whatever it was plus the interest. But from the previous, we can also see that the amount can be found by taking the principal plus the principal times rate times time. which is kind of interesting. All I did is took that interest and replaced it with that interest formula, you'll notice, which is kind of cool. Gosh, I love math sometimes. Or I can actually take the p out of both of these terms, and sometimes it's more convenient for us to use p parentheses 1 plus rate times time, and oh my goodness, doesn't that look familiar? This right here, this right here should look something like the result is equal to the base. 1 plus means markup, rate and time. Ooh, should all start to come together, feel familiar. Again, these are very important formulas for what we will be doing in this next section. So please make sure you're taking these two specifically and recording them somewhere, using them as you're going through these different questions. Okay? Okay, so here I did take a question that I think will be a little bit applicable, a little bit hands-on. Let's see what's going on. These are much like our percentages where I do still want you using your underlining, highlighting, keeping track of key pieces of information as you're going through it. Okay. Beth is the owner of a small retail store in downtown St. Louis. The windows in the storefront need replacing. St. Louis had a storm, man. Okay. So she needs to take out a $9,500 loan. Okay. That means she needs to borrow money she doesn't have yet to replace the windows so she can keep her business open and make more money. But the rate she secures is 9.25%, and the term of the loan is 1 year. So in 1 year, she has to pay back the loan, but also pay for getting to use that money, thus interest. Okay, how much interest will she pay and how much total will she repay? So there's two parts of this question. All right, let's dive into our pieces here. So she takes out a loan for $9,500. That's a principal on the loan. That's a principal on the loan. The rate she secures, again, those rates often come with those percentages, so that's really nice. That's our rate. And the term of the loan is 1 year. So she has 1 year again to pay it back, okay? Now I'm going to underline this part. I need to answer how much interest she will need and how much total she'll have to pay back. Okay. But she gets to reopen her business. So hopefully she can make it back and make it really worthwhile. Now, the first question is about interest. I want to rewrite my formula. Interest equals principal times rate times time. Okay. I kind of wish the loan had been for 2 years. So you could have seen it two go in instead of a one, but that's okay. We'll work it like it is. Then the other formula, the other piece is how much will she need to repay? That's A for the amount of the loan will equal to P. I'm going to do the 1 plus RT, and we're actually going to see that it lines up with the other versions of the A formula. Okay, for amount formula. So interest, the interest she needs will be the $9,500. And then remember that percentage has to be turned into its decimal form, so 0.0925 rate, and then a time of 1 year. I used parentheses to stay organized and indicate multiplication. So again, since there's no symbol between those, multiplication. All right, and now I'm going to call up my calculator because I ain't doing this by hand. No, thank you. I have 9,500 times, or just parentheses, 0.0925 parentheses 1, boom. The interest the cost of being able to use somebody else's money as a loan is 878.75. So 878.75 is the extra money on top of the value of the loan that she'll have to pay. Interest. Okay, which means that over here now, let me make that a little smaller. The amount of the loan, again, we can use our formula of $9,500 for our loan, 1 plus 0.0925 times 1. And if I go ahead and plug that in my calculator, 9,500 parentheses 1 plus 0.0925 times 1 is this amount. Hey, look, that's just if we take the amount of the loan plus the interest we just calculated. Oh, same thing. Same number, same value, because the ending amount she needs to pay back will be $10,378.75. So that's the ending amount of the loan, $10,378.75, due after 1 year. Due after 1 year. Aha. Aha. All right. So that's what Beth, the business owner, needs to keep in mind because she had to replace her windows. Okay. The amount at the end of a specific time period under an interest rate of growth, again, is in your book and often called future value. Future value. And this is just another spot to include one of those other formulas. But again, you'll often see a formula like future value equals principal plus interest. Ooh, interest. Interest. There we go. Doesn't look like one. Okay, future value. Again, so same amounts, A's that we were using up above. Okay. Now, if you haven't heard of a CD, CDs are pretty cool. CDs are certified deposits where a bank agrees to take your money and then pays you back for being able to use your money. So let's go ahead and get a highlighter here. Mia deposits $4,900 and a CD bearing 3.95%. Okay. Now, what's nice is that a CD guarantees that growth. There are other types of investments you can make that often will result in greater growth than that, but they aren't always guaranteed. Sometimes you might lose. CDs, you're guaranteed that growth. Okay. The term of the CD is 7 years. That's how long you have to leave the money alone. Okay. When she redeems the CD, how much will she receive? Okay. How much will Mia receive? Well, she'll receive back the money she put in and some interest. So Mia will receive a future value, you could either use FV or A is equal to, you can use principal plus interest, but then we got to go in and we got to figure out interest, or again, we can use our formula P1 plus R times T. Let's make that a nice times. R times T. Okay. So our future value, oh well, let's see. Future value, we don't know. You can also be using A. Again, I know it looks a little strange. They mean the same thing. 4,900. 1 plus, ooh, I gotta convert. Almost forgot to convert. 0.0395 times 7 years this time. 7 years this time. All right. 4900 parentheses 1 plus 0.0395 for our rate, but then times the 7 years. And we get a future value, an amount Mia will receive at the end of $6,254.85. Now again, she only put in $4,900. So what did she have to do for that extra money? Let it sit and grow. She had to let it stay locked away in the CD for 7 years, and then she gets a larger bit of money. Okay, so that's how CDs work. Oops, sorry. Sorry, guys, my iPad's being a little weird. So as we mentioned, we see APR. Again, APR, A for annual, means that our rates are coming to us as a year rate. Rates in year rate. Okay, so our rates are coming to us in a year rate. What happens if we don't have a CD for a full 7 years? What happens if we have a CD for only 7 months? Now that's going to be a little bit different because we are still going to get some growth, but we're not even going to get one whole year worth of growth. We're only going to get a portion of that. Okay. So what happens when we have simple interest loans with other lengths of terms, other times that we are investing them in? So here, for the first example, Samuel needs to borrow $8,400 to pay for repairs to his manufacturing facility. He manages to get a simple interest loan at 17.33%. Holy Toledo, that's high. Samuel, you might have some bad credit, or it might just be like a crazy period for the economy. But he's going to have to pay back in just 6 months. He doesn't even get a full year. He gets 6 months, okay? How much interest will Samuel pay? And what will the loan payoff amount be? how much interest, and loan payoff amount. Okay, so again, a two-parter question. Let's do a quick little note up at the top here. Note, there are 12 months in a year. There are 4 quarters in a year. There are 52 weeks in a year. I know it's not exact, it's weird. Banks use that number. And 365 days, even though on leap years we get 366. So the number is actually 365.249. Whole separate rant I have. But I just want to keep these in mind. These are the different amounts for 1 year. All right. So now here we have a principal amount. Here we have a rate. And our term now, our time is not 1 whole year. Our time will be 6 out of 12 months because you need to make a ratio. You need to make a fraction with whatever unit you have and how many it takes to make a year. So 6 months when it takes 12 months to make a year. Okay, so I know that's a little small, but I made that ratio there. I'm going to go ahead for my rate. I just want to convert it now. Boop, boop, 0.1733. And again, my principal from up above was 8400. Now, again, I have two questions. This is a two-parter. I need interest, which is found just like before, P times R times T. You don't have to put multiplication symbols. You can use parentheses or just write them next to each other. And I have a question about the future value. The ending amount of the loan will be P1 plus RT in that parentheses. And here we go. So here we have 8400 times our rate of 0.1733 and a time of 6/12. 6 months out of 12 months for a year. Okay. And I love your calculator. If you were careful, you can put it into your calculator exactly like we see it. 8400, 0.1733, and then another parenthesis. I had to close and then open again. 6 divided by 12. Oh, look. And then I close it and it looks just like I wrote it. So the interest on the loan will be 727.86. An extra $727.86 for Samuel to borrow this money to fix his factory. Now, if he needs it to fix his factory, he needs it. So that's what he's got to do. Now, over here, the future value is how much he'll have to pay back at the end. We have the same $8,400. 1 plus that rate was 0.1733, and the time is still that fraction of 6/12. Now, I am careful with my parentheses. Notice how I have the nested parentheses in here. So when I plug it into my calculator, 8400, open, 1 plus 0.1733, another open, 6 out of 12, and then close. Oop, over arrow so I can close and close again. And now we're ready to rock and roll. $9,127.86. He will owe, Samuel will owe 127.86. Okay. So now again, that's a different term of loan, a different term of loan. Okay. Here in your book, they have a separate understanding and compute future value, which I think is kind of funny. We've been doing that the whole time. Okay. So you can compute, or we can compute the future value, which is the amount at the end of the loan or term. The end of the term of the time of investment. Okay. A certified deposit, CD, that we just talked about is a savings opportunity. I don't know why the book has this out of order, but that's okay. We'll keep going with it. And then the future value, I just want you to write down this formula again, future value or A, principal 1 plus RT. Let's make that one really clear with that parentheses closing us in really nicely. Write this down a couple of times, you guys. This future value is the ending amount. P for principal. 1 is 1, R is our rate as a decimal, and T is the term or time of the loan in years. Time in years. All very important. Okay, please be careful about that. Okay. I would like you to go ahead and I would like you to tell Jonas if he deposits $2,500 in a CD bearing 3.25% interest for a term of 3 years. When he redeems the CD at the end of 3 years, how much will he receive? I want you to write this out. I want you to give it a go, pause, take whatever time you need. Okay. We are going to now go on to compound interest. Compound interest, still this like growing idea, but compound interest is a little bit different, a little bit excellent and weird and kind of quirky, but actually how a lot of things, including credit cards and other types of loans, work. Okay. So compound interest, compound interest. If the amount of interest that we calculate, that we find grows every single time because the rate is being applied to a new bigger and bigger and bigger amount, then we have compound interest. Compound interest. My favorite story about this is Compound Interest by your favorite aunt, you know who. And what happens if, let's say, I take and I put in $1,000 for my nephew Joe, for Joe, at 7.45% for, let's say, until he graduates and needs that for college for 18 years. Compounded yearly. Ooh, compounded yearly. Now, what does that mean? What does that mean? That means that every year they're going to take the interest that it grows and they're going to add that to the new total. They're going to add it in, which is, oh my gosh, it's going to be so great for Joe. Okay. Now, here's the thing. You are never, ever, ever going to find a 7.45% for 18 years. 18 years, no bank is going to guarantee that. That's such a crazy high rate of growth to guarantee for 18 years, and I'll show you why. Let's take a look. So at year one, Joe will have $1,000 plus the interest, plus the interest. So plus $1,000 times our 0.0745 for 1 year. Okay, so I need to bring up my calculator so that after 1 year, Joe is going to have $1,000 plus the interest of 1,000 times 0.0745 for 1 year. Okay, so at the end of 1 year, Joe is going to have 1,074.50. Okay, but year two is going to look different because it's not going to take that same $1,000 to find your interest again. It's actually going to take this new 1,074.50 and find the interest on that. So we got to take this 1,074.50 and a new interest using the 1,074.50. New interest. Oops, 4 5 times 1. So let's see what's going on here. So now we're going to use, I showed you guys, double tap plus double tap parenthesis 0.0745 times 1 times 1. Oh my gosh. Okay. $1,154.55. Okay. So it came up with even more interest. Even more interest. Check this out. It had a full $80 of interest this second year versus only 74.50 the first year. So there's 74.50 for the first year of interest, but 80 for the next year of interest because that principal is growing. Since that principal is growing, it's compounding, you actually get even more. Let's check out year three. So year three is going to use the new value of 1,154.55, 1154.55 plus the interest 1154.55 times our rate of 0.0745 for 1 year. Let's see how much we have after 3 years. 1154.55 plus 1154.55 times 0.0745 times 1 year. And okay, here we go. At year three, $1,240.56. So let's see how much interest there was just that third year. Just that third year, holy Toledo, $86. And the interest keeps growing because the principal keeps growing since we're compounding. Now, I don't know about you. I don't want to do this like for a whole bunch. That sounds like kind of a pain. It sounds like kind of a pain. Let's see if we can find a pattern that's going on here. Okay, a pattern, a pattern. So we had our first $1,000, and then we were able to take a 1 plus 0.0745 times 1 year, right? Right? Now, again, this amount here became my new principal. This amount here became my new principal in both of those spots. So I could even have plugged it in. So the next year, I really had the 1,001 plus 0.0745 as my new principal. And I multiplied that by 1 plus 0.0745. Let's double check on the calculator. So we had our $1,000 times 1 plus 0.0745. Okay, there was that first year. And then we multiplied it again by 1 plus 0.0745 for the next year. Oh yeah, look, that 1,154.55. And I bet you this next one will come out to where we have 1,000, 1 plus 0.0745 once, and then twice, and then 3 times. Let's double check it. On my calculator, 3 times 1 plus 0.0745. Aha! 12, 40, 56. Ah, there it is. Okay, so we're repeatedly multiplying. We're repeatedly multiplying by this 1 plus our rate business. So repeated multiplication, year three, we actually saw the original principal of the loan and 1 plus 0.0745 repeatedly multiplied 3 times. Oh, we get to use those exponents now. Those exponents are coming in, which is why we needed that review from part three. So I bet you year question mark, whatever year we want, we'll be able to take our principal time 1 plus our rate of interest growth times itself that many years time. Oh, I'm gonna replace this question mark with maybe just a T. We've been using T for years, so let's make that a little T. I like to put little tails on my T's so they don't look like a plus. Ah. So now, instead of repeating this every time, I could say, hey, at year 18, Joe will take this $1,000 and multiply by 1 plus 0.0745 18 times. 18 times for those 18 different years. And Joe will come out with 1,000, 1 plus 0.0745 up to the 18th power. Now, you'll notice that I tapped and I held on my A to the 2 power button to make sure I got an exponent up there. I need to make sure that 18 is little tiny up in the corner for repeated multiplication. $3,645.15 after 18 years. Now, if it had just been straight simple interest, it would have been $1,000, 1 plus 0.0745 times 18 on the inside of that parenthesis, right? And that's only $2,341. So look at how much bigger compound interest got over the same 18 years. That's kind of crazy. All right, so here's another one of those big formulas I want you to remember, I want you to have. We're going to have future value is equal to principal 1 plus our rate to the time exponent, okay, for compounded yearly. Compound yearly. Now, Anna, does that mean you can compound other times? Sure does. Sure does. You can also compound n times a year, and this one's going to be even more important for us. Future value is equal to the principal, 1 plus the rate, because it's a yearly rate, we have to divide it into n times, up to the n times t power. Now, oh my gosh, you guys, this one, again, big guy, big guns, big guns. We got a lot going on here. Okay. We got a lot of pieces going on. I want to break this down very specifically. Okay. Future value is our ending amount. P is our principal. R is our yearly rate. Our yearly rate, our APR, right? But that's the yearly rate. And so sometimes we break it up into n times a year we compound. N times a year we compound. Okay, with t being our number of years. Number of years. As a reminder, when you see something like annually, n will be 1. Quarterly, 4 quarters and $1. Weekly, 52 weeks in a year. Semi-annually means twice a year. Monthly will be 12 times a year, and daily will be 365 times a year. And I'll be real honest, a lot of my students, when they try to do daily things with those exponents, you break the calculator. So you might have to turn to Google if you're doing some of those. Google. Or there's a site called Desmos that has calculators that don't break when you try to do a 365 up in those exponents. Okay? So now let's check out what's going to happen with Abina when Abina invests. Let's see, Abina invests $1,000 in a CD, earning 4% compounding annually. How much will Abina CD be worth in 3 years? What if we compound monthly? Which one would we prefer and why? Okay, I'm going to change this up. I want to make this a little more interesting. Instead of just $1,000, let's invest $200,000. I want to really see some differences here. Okay, so this is going to be changed in your notes. So I want you to full on change it for me. We're going to work with $200,000. And we're going to look at 4% compounded annually. We're going to change annually. I want to change it to monthly. Oh, wait, we're already going to do monthly. Never mind, never mind. Go back, undo. There we go. We're going to do annually first and then monthly. So we're going to check out both things. And then again for 3 years. 3 years isn't a lot of time, but let's check it out. Let's see what's going on. So I want us to write our formulas again and again and again to make sure we're clear. Since we see compounded, the word compounded, I know I need future value is equal to principal 1 plus our rate over n to the n times t. Now, just to be extra clear, over here, I'm going to say future value. We don't know what that is yet. Our principal is going to be that 200,000, lots of zeros to keep track of. Our rate is 4%, but I want to go ahead and convert that to its decimal form, 0.04. Our T is 3 years. And N for the first time compounded annually is just one time a year. One time a year. Okay, so here's all these pieces. Future value, I don't know. I'm going to put a question mark. P, I'm going to put 200,000 parenthesis 1 plus 0.04 over one time a year to the 1 times 3 years. Okay. And I want to be very, very careful plugging this into my calculator. Please use your calculator. Please use your calculator carefully. Okay. So I need 200,000 parentheses 1 plus 0.04 divided by 1, and then I use my over arrow. Now again, I click in them, I hold that A2 button to get an exponent of 1 times 3 years, and Abina will have 224,972.8 or $224,972.80. Okay. Now, what's great is when we change this to monthly, the thing that will change will be the n, and the n will be 12. N will be 12 here. So over here, I'm going to rewrite. I'm going to say future value is equal to principal 1 plus rate over n to the n times t. And now our future value, our question mark, let's go ahead and put question mark will equal that 200,000 1 plus the same 0.04, but now over 12 up to the 12 times 3 power. So that 12 times that 3, that 36 times is up in that exponent. Up in that exponent, okay? And what I love about my calculator is, let's say I entered it, I can actually double tap that previous line, and I'm going to tap back in. I'm going to change that 1 to a 12, and I'm going to change that one to a 12, and I have my new formula ready to go. And we get 2,254,5,4.37. Same? Are these the same? Nope. We have almost $1,000 difference. Almost $1,000 difference. $225,454.37 if we compound monthly over if we compound just once a year. So compounding more often will actually grow us faster. Okay, that's actually a really cool fact. Fact. I'm actually going to write that down. Fact. Write this down too. If all else is the same, the higher n, aka more times a year compounded, more times compounded, will be a bigger future value. Future value. Again, if your rate's the same, your time's the same, if you have the same principal amount, a bigger N will result in a bigger amount of money. So that's something really nice to think about. That's something to keep in our back pockets. Okay. I would like you to take a few minutes. I would like you to see if you can pause and set up what we need here in this question. All right, so I underlined some key pieces here. Again, I hope you pause and sit and work with this one. This one's a little bit different because it doesn't have an initial amount and then an unknown ending amount. It actually has a known ending amount. Hejun will need $1,200,000 to $200,000 to retire comfortably. Okay. So he's got that like end goal in mind. Okay. He has a retirement rate here. And we know we're compounding monthly, but the question is, how much will he need to invest? What is the principal of the investment he needs to make at 30 so that at 65 he can reach his goal? Lots of pieces here. So first of all, we are compounding, so I hope you put future value is equal to principal 1 plus r over n to the n times t. Future value now is this $1,200,000. Okay. The principal is the thing we don't know. That's our question mark. The rate is going to be 0.0723, that rate converted. The N will be monthly of 12. And the T is a little weird. We need a 65 retirement minus 30 that he is now is 35 years. 35 years for the term. Okay, now this is very silly. Almost nobody takes a lump sum and puts it in now and just waits 30 years. They add to it as you go, which is one of our other sections in the book. So if that feels a little fake, it is a little fake, but it's going to give us a really cool question here because we're going to get 1,200,000 equals question mark 1 plus 0.0723 over 12 up to the 12 times 35. And we're like, oh man, our question mark is in here. But really, our question mark, our principal, is multiplied by this whole number that our calculator can actually tell us. So let's have our calculator actually tell us. This whole number, parentheses, 1 plus 0.0723 divided by 12 over arrow, close the parentheses, up to the 12 times 35. Aha! Is this crazy 12 number. Now, I actually don't want you to write this down. I actually want you to say we're going to divide by all this stuff that we're going to get here. Okay? And we're going to do that on both sides, which means that to get question mark alone, I actually need 1, 2, 0, 0, 0, 0, 0 divided by, and I am going to double tap that stuff, all that stuff together. And my calculator will keep track of it for me so that I have 96271.23. Okay, so Jesus needs now to put in $96,271.23 for 35 years to reach his goal. Okay? That's how much he needs now. And again, your calculator is going to be great at this. I want you to go through, I want you to practice plugging those in, double tapping, making sure that it works out clearly for you. All right. And again, maybe give yourself a little caveat. This isn't a super real life situation, but maybe Hejun is a person he's decided to sell his business and he's going to have this $96,271 he can put in and leave for his retirement. Okay. So not overly realistic, but something to think about. Okay? Something to aim towards. Okay? The last type of compounding we're going to talk about is something called compounding continuously. So imagine if instead of daily, you went hourly. But even instead of hourly, you actually compounded every minute. But instead of every minute, even every second, if you could compound every single second, how much money will you have? This actually needs a special number known as E. And if you look at your calculator, E is actually down here if you click and hold pi or if you click and hold 5. So if I click and hold 5, I get E, or if I click and hold pi, I get E, and it's the same number both times. It's the special number 2.71828 stuff forever. It's actually like pi in that it will go on forever. Okay, so this future value is not going to use a 1 plus anymore. This compounded future value is still going to use the principal, but then we're going to multiply it by e. We're going to multiply it straight by e to the r times t power. So p is still our principal. E is this new special number. R is still our rate, and t is still our time, but we are compounding continuously every single instant. Every single instant we can compound, we are. Every instant. So again, if you see the words compounded continuously, compounded continuously. Okay. So here, let's see if would you rather have $7,000 in an account compounding quarterly for 5 years at 4.3%, or a different account compounding continuously for 5 years at 4.29%. Now you'll see a lower percent, but more often. Okay, so let's see which one of these accounts is going to be better for us. I'm going to divide this over. So the first one, future value compounded quarterly, I need to use P 1 plus R over N to the N times T, versus the second one where I see compounded continuously, future value is P E to the R times T. Okay, so in the first one, our future value we don't know. We'll be working with our $7,000. 1 plus our rate of 0.043 over 4 quarters in a year to the 4 times 5 years. Okay, if you need to stop and write out each of those pieces separately, I encourage you to do so. Okay, so I read them over here. I got our P principal, our term 5 years, our rate, and then that quarterly for n equals 4. Okay. And I'm going to go ahead, I'm going to plug that into the calculator at a 7,000. 1 plus 0.043 divided by 4. Exponent 4 times 5. And we have a future value of 8669.08 or $8,669.08. Okay, that's compounding quarterly. Now let's check compounding continuously. Future value, principal of $7,000. E is the number E to the rate of 0.0429 times 5 years. Okay, slightly lower rate, but higher compounding. So let's see what would be better. I need 7,000, oop, too many zeros, times our E up to the exponent 0.0429 times 5 years, and ladies and gentlemen, a future value of 8674.69. Here we have 8,674.69. A little bit more, even though it was a lower rate. It compounds enough. So we should tell whoever we are asking, actually, please put us in the continuous account. Continuous account is better. Continuous at 4.29%, please. That's where we want to be. Okay. Now we're actually going to save effective annual yield for class. So you don't need to worry about that right now. Ladies and gentlemen, we are finished with these notes for now. Yes, it has been a big video. It's a big set of notes. So please take your time. Feel free to break it into a couple of sessions as you need to. But I will see you in class and come prepared. We're going to do some money stuff. I'm super excited. See you then.